Welcome to Geometry. We're on lesson 5-5. Today's date is January 28th. Make sure you have that date and your name on your notes. Here we go. Review. Our review. If I have this angle of reference, we'll call that theta, and I already gave you adjacent, opposite, and hypotenuse, what is sine? What ratio is sine? I should be seeing like tons of hands, like half of the class. 9 people should be raising their hands. Cheyenne. It is indeed opposite over hypotenuse. Write it down. Make sure you have it in your notes.
Opposite. Synonym, a pen. A pen would be fun.
And then Martine participated for our warm-up. Thank you, Martine. Now everyone's up to date. You can turn in your card. Thank you, Cheyenne. All right, cosine. What is cosine? Tons of hands, tons of hands, tons of hands. Chewy.
Adjacent over hypot.
Adjacent over what?
Hypot.
Over what?
Hypot.
Over what?
Hypot. Hypot.
Okay. Well, we'll take it. We'll say it's hypot.
Do you know who Key and Peele is?
I do.
Yeah, did you see their one on hypotenuse?
I did not. I need to watch it.
He's like, I was
Mathematical
on
humor? That is
hypotenuse.
so me. And then tangent. Tangent is Emily.
Opposite over adjacent.
It is indeed. Opposite over adjacent. It makes the oa sound. Toa, soa, ka, toa, soka, toa. There we go. All right, so let's talk about going backwards. In math, we want to go forwards and backwards. Sometimes it's impossible when we get to higher level math. Nice shot. All right, so how can we solve for theta in this problem? Sine of theta is equal to 1 over 2. Sine of theta is equal to a half. How do I get theta by itself? How do I undo sine? How do I go backwards from sine? And you can do it. Does anyone know this already before I jump into it? No one knows? Cool. All right. So here's the answer. You go backwards by taking the arc sine. Sine to the negative first power of this side, and you take sine to the negative first power of this side. This is pronounced arc sine. We take arc sine of both sides, and by doing that, go ahead and write this down too, we cross out the arc sine and we cross off the sine, we're left with theta by itself. Arc sine and sine cancel each other out. To go backwards from sine, I take arc sine. So far, so good. This is the logic. This is something that we've done already. If I take the opposite over hypotenuse, so let's actually say I have an angle. We know how to do this. If I have an angle and I take sine of that function, it will tell me what the, I keep saying this so backwards. Before what we had for our warm-up, we had this angle, and then we were trying to figure out what these ratios were. We can all nod our heads. We were trying to figure out what was this side. In order to find the side, we had to take sine of this angle to find what that was. So I'm going to write here sine. We had an angle, we took the sine of it, and it gave us the opposite over the hypotenuse. Well, what if I started with 1/2, just like this original problem, and I want to go backwards to find the angle? That's what we're doing today. Today is going backwards. This is backwards here. Backwards means we take the arc sine. So if I have opposite over hypotenuse, to go backwards, I take the arc sine to find the angle. And I can go forwards again by taking sine of that. And by the way, if I do that on my calculator, just to see what that turns out to be, make sure that radians is shown. That means I'm in degrees. We just went over that for the warm-up also. If I take sine of 1/2, so 1 divided by 2, oh, I don't know why I said 5 there. 1 divided by 2 is 1/2, and I take arc sine of that. The way that I do that on my calculator is I hit second, and now I have the sine to the negative first power, which is arc sine. Arc sine of 1/2 is 30. The angle here was 30, so we can write down also if you, well, what just happened? There we go. We can say that our angle here was 30 degrees. All right, so how do I analyze our inverse trig functions? So these are all of the 3 inverse trig functions that you need to know. I take arc sine of opposite over hypotenuse, and it spits out our angle. This will be equal to an angle, so we can say theta is equal to this thing. theta is equal to this thing. It's equal to all of these things. Another way of saying this is by actually saying arc sine. This is valid. Instead of saying sine to the negative first, you can just say arc sine. They're the same thing, and it's pronounced, as I've been saying, arc sine. Let's all say that together just to make sure we got the pronunciation right. On 3, we're going to say arc sine. 1, 2, 3. Oh man, that's a handful. Easy money, right? All right.
Yeah, that's not a
Then we have arc cosine and arc tangent. All of those we know, we have seen them. Let's move on to a misconception that I hate. I hate this so much because this is really poor notation. Whoever invented the notation, we need to look them up and then give them evil glares because they have horrible notation. So this is true. If I have 3 to the negative first power, it is indeed equal to 1 over 3. But sine to the negative first power is not equal to 1 over sine. So don't think of this as 1 over sine, just think of it as arc sine, its own function that goes backwards. By the way, 1 over sine, this does have a special name if you guys want to know it. This is Algebra 2 level stuff. This is called cosecant, CSC, cosecant of x. You'll never need to know that for this class, not until you get to the next class. What's up? Why is your hood back on?
Sorry, I was really no. You don't even grab handfuls. You don't even grab handfuls.
That's like a
A
Google
Google
handful.
Okay, I'll do bigger handfuls.
Thank you. Because if you were to grab a handful of
Example 1.
chips, it'd be a lot more than that.
Trying to call me fat, I see. Example
No,
1.
Gold chips like gold. You grab a lot more of a handful of that.
Oh, okay. I thought chips. Okay. Okay. Find the measure of angle B. So they gave us the ratio. They gave us this ratio, and we need to find the angle. They gave us this ratio. We need to go backwards to find the angle. We're going to be doing a backwards function, an inverse trig function. All right. First of all, we need to figure out which trig function we're using. Quiet raised hand. Which trig function are we going to be using? So, ka, toa. Which of those are we going to be using? Quiet raised hand. There's only 2 people that know. I mean, you have a 1 in 3 chance of getting it. You're either going to say sine, cosine, or tangent. One of those 3. What are they going to be? I'm going to wait for one more hand. We have 4 hands so far. There's the 5th hand for Caroline. I'm going to call in Lorea. It is indeed tangent. Tangent of that unknown. I can put question mark here if you want. I can put theta there. You can put x there. Whatever you want. I'm going to put theta because that's the general way that we say things. Tangent of theta is equal to, let's come back over here and give Lorea her XP. And then what is my fraction? Quiet raised hand. Lorea answered. What is my fraction, India?
65 over 30.
65 over 30 like that? Oops, 65 over 30 like that?
No,
No?
it's 30 over 65.
Ah, there it is. 30 over 65. That is indeed correct. So thank you, India. Also, I forgot to give Martine and Emily. Okay, now we're all caught up on marbles. And let me see if I caught up on here. Good, India's all caught up. Okay, so I have this function set up. But now I need to solve for this theta. I need to somehow undo tangent. What am I going to do? Quiet raised hand. How am I going to undo tangent? There's only one person that knows. Raise your hand if you have a card and you know. Only one person, 2 people kind of Leo, no? Okay, Ellery.
You multiply by negative or arc tangent.
So yeah, you're correct in using the arctangent, but the way that you said it is a little bit off. You say you take the arctangent of both sides. So take the arctangent of that side, take the arctangent of that side, and that will cancel out our tangents. So we have an arctangent and a tangent. I'm just left with theta. Now we're going to be approximating because we're going to be rounding, so I'm going to do our little squiggly approximating equal sign. All right, I need someone to pull up their calculator. Do this for me. Someone do 30 divided by 65 and then take the arctangent of it. So Ellery, you got your XP and marble. Someone new, someone that hasn't participated yet. There aren't many chances to participate in this lesson, so I need everyone to participate today. Even if you have participated, go ahead and do this on your calculator so you can be confident in your ability to use your calculator on your phone. Do 30 divided by 65. Take the arctangent of it. Make sure you're in degrees. What is our angle?
Yes.
Uh-oh. Did you do 30 divided by 65?
I don't know if I did right. You do 30 divided by 65, and then you do the other thing.
And then hit equals to get what 30 divided by 65 is. So 30 divided by 65 equals.
Wait, Mr. Sindel, is it supposed to be in degrees or?
It needs to be in degrees, which means radians is in the bottom left. It shows radians in the bottom left. All right, Aurelio, go for it.
No, I'm just kidding.
Beverly, go for it. Do you have your participation card still?
Yeah.
All right, go for it.
27.49.
4.49, yeah, that is the right answer. All right, so let me show you guys how to do this on your calculator.
Wait, I got 11.4. You're wrong.
Well, you did it wrong.
You're wrong.
All right, so make sure that radians is showing in the bottom left-hand corner. That means that you are in degrees.
You just in the bottom left.
All right, now I'm going to do 30 divided by 65 equals. It's this decimal 0.4615, blah, 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 blah. Now, this represents a fraction. Now I'm going to take arctangent of this fraction. So make sure it's tan negative 1. You have to hit second to get there. Tan negative 1 of that. And you, ooh. Uh-oh, that is not quite right. It should be 24.775.
What?
No, I put sin. I did a sign. Sorry.
You did arc sine? Ah, okay. You sinned in my classroom by using the wrong function. So 24.7. All right, I need someone to round this correctly for me. 24.7. Quiet raised hand. Beverly, why you do this? Martine. Yeah. Thank you, Martine. Did I give Beverly or Aurelio? No. Beverly, you knew what you were doing. You just took the wrong function. Martine, you rounded it correctly. Wait, Martine, you already participated.
Oh my god.
All right. Go ahead and box it. That's our final answer. Don't forget your units. What were our units here? Degrees. That little symbol. Degrees. Kind of like Fahrenheit. Degrees. That is degrees. If it doesn't have a unit, that means if it doesn't have this symbol, then it's in radians, which is not what we were doing. All right. Radians is unitless, by the way. So let's go on to example 2. I want to find this unknown angle. We'll call it theta. Round to the nearest thousandth. So first question that I have for you. Which trig function are we going to be using? You have a 1 in 3 chance of getting it. It's either sine, cosine, or tangent. Raise your hand if you know it and you have your participation card still. What trig function can this be? I know there are some people that know this that already participated. What trig function? 2 people know. I'm going to wait for 3 people. Wait for 1 more person. I might. 1 more person. Which trig function is it? Aurelio.
Yeah, that's right. Cosine. No.
It is indeed cosine. Cosine of our unknown angle theta. We'll call it theta instead of question mark. All right. Thank you, Aurelio. You are in Class Dojo, which is going to load right here. Nice shot.
Whoa.
Ooh, cool sound. All right. Coming back here. I need this fraction to be set up for cosine. Who can help me set up that fraction? Quiet raised hand if you have not participated before. There's only 1 hand. Uh-oh, that's not good. I'm going to wait for 3 hands. 2 and 3. Caroline. 7 over 9 like this. That is indeed correct. Thank you, Caroline. All right, and now what am I going to do to both sides? I need to get theta by itself. Right now, theta is trapped inside of this cosine function. What am I going to do to both sides? I see 1 hand. I need to see 3 hands. 2. And 3. Colby. Arc cosine of what? Arc cosine to both sides. There you go. Arc cosine of this side. Arc cosine of this side. All right, thank you, Colby. All right, and our final volunteer for today. Use your calculator. Find what arc cosine of 7/9 is. arc cosine of 7/9. Everyone be doing it on your calculator. Make sure you know how to do this. 7 divided by 9 equals this. And then I'm going to do arc cosine of this. And you're going to have to round correctly. Raise your hand if you have an answer and have not participated yet. I see 2 hands. No, you've already participated. Go for it, Sam. 30.94 like that. 38.94. 38.94 like that. Degrees. Let's check it out. So we took the arc cosine, 38.94, and it was rounded correctly. Good job, Samantha. And last step, Samantha, is to box your answer. There it is. Thank you, Samantha. You can turn in your participation card. XP, marble, all the jazz. All right, are there any questions about this lesson? Any questions? All right, if you have not turned in your participation card yet, please do so now. And then you may begin on the summary. After the summary, you can begin on the homework. You have paper homework or Khan Academy homework. It is up to you.